We actually have Hayden and Derek Sikora gonna present on Vita Inclinata technologies, as has developed load stability systems that use high power propulsion to eliminate chaotic motion at the end of the suspension load. I kind of want to start bringing in new technology, and if there's any new technology out there that any of you know about, let Carrie and I know so that we can start looking at different things to bring about for the group, and we'll put a technology line item in the agenda just to kind of show everyone some new technologies that are out there. Okay, Hayden, I'll turn it over to you. Thank you.
Perfect. Well, welcome everybody. My name is Hayden Hunter. I am the Regional Relations Manager with Vita Inclinata. First to check, can everybody see my screen all right?
You're looking good.
Perfect. As Willie mentioned, I'm here with Derek Sikora, our Chief Technical Officer, as well as co-founder of Vita Inclinata. And we wanted to talk to you today about the load stability system. So the load stability system is an innovative piece of hardware that we created here at Vita about 8 years ago to solve the chaotic motion that happens at the end of long line helicopter rescue operations. We had such wild success over in the DoD and the military side of everything that we brought this same technology and all of its benefits over to the construction industry. And as Willie highlighted upon, the system is a thrust-propelled stabilization unit. Essentially what that means is, as you can see in the diagram to the left, it has these 4 high-powered electric duct fans housed within that plastic casing underneath the roll cage there. And then also within that roll cage and the plastic casing is the battery. It is a battery operated system, completely self-contained with a very short charging time to offer all this swing and rotation control for your suspended loads. As you can see in the picture to the far right there, that is a demo unit of our system using a man basket. And we were just trying to showcase how it has precise pinpoint control of its picks while it's in operation. Also in the diagram to the left, you can see the hook that is attaching to the crane. It's just a repeat of one process there. You would attach it to your rigging and then attach it to your suspended load to the attachment underneath for very minimal learning and training on that end. How the load stability system works, it first senses any sort of motion that happens at the end of your rigging operation. It then interprets that data and outputs it to those high-powered electric duct fans to stabilize and hold your load plumb during your entire operations. So the load stability system offers automatic and direct rotational control of loads scalable up to 66,000 pounds at the moment. Its operation time is 8 hours, and you're using that handheld control remote pennant device that you can see in the picture to the right. You would actually be able to rotate your suspended loads 90 degrees in 15 seconds, 180 degrees in 30 seconds, or you can go full tilt in less than a minute. The core features that surround this technology is the precise automatic and manual control of the system. So manually, as you just saw above, you would be able to, with the flip of a button, just rotate those loads for precise pinpoint picks with a low margin of error. Whereas when the system is automatically turned on, it will sense and adaptively stabilize based off of wind increments. Say you have an operator out there that's cowboying the load, it would be able to counteract that and still hold the load plumb underneath your crane's boom. The benefits of the load stability system for crane operations is essentially the elimination of taglines. You're going to have faster, safer lifting operations with an easy-to-use system that requires minimal training and maintenance. That diagram at the bottom that shows the 31% is a risk assessment that we did with a risk assessment company called Max Safety. Essentially plugging our load stability system into their already running algorithms, we can show a 31% reduction in all risk for crane activities. And that comes from eliminating slip strips and falls near the crane site, getting rid of potential pinches, as well as just eliminating people from the load path overall. As you can see in the graph to the right, using that same algorithm, we can show that the load stability system offers 3 times more risk reduction than what the normal taglines would offer for crane operations. And this is so you can see what the LSS is like in action. This was a demo that we did with a company called Erection Crane and Rigging out here in Colorado. And this is to really showcase how the system would handle and deal with these larger dimensions and heavier loads. You would still have that full control to be able to actually pinpoint your load and have a very low margin of error for any sort of accidents in that front there. Some of the past companies we've done demonstrations with, such as Miller and Long and BAE Naval Shipyard, really showcased how the system would work with, say, large loads in the precast concrete industry. We could really demonstrate that kiting factor and how the system would adaptively stabilize rogue winds when it hits that sort of kiting factor. As well as with BAE Naval Shipyard, we got to go out and showcase the system on the shipyard, where we actually showed how the system would react to their loads in regards to ship repair and shipbuilding. And with digging and rigging, Erection crane and Duffy crane and heavy hauling, we actually got to take it out to their yard, hook it up to their booms and their trusses, and show how it would work in erecting a tower crane and such like that. The use cases for the load stability system is vast. Essentially, we see the system being able to work in steel erection, precast concrete, oil and gas industry, modular building, all the way to renewables. The system itself is modular in design for tackling the wind turbine erection industry. The system is cut in half, essentially, allowing for it to attach directly to the blade gripper. And then the power can be scalable at that point. So you would either have more fans or more batteries so that you can have that continuous blade gripper control throughout your entire operations. Same within the oil and gas industry. This would also be a modular system. We would essentially put a spreader bar in between it, taking it out of the load path so that we can mitigate those 66,000 pounds. But this would be the ultimate solution to downtime within the oil and gas industry. No more ship-to-shore transfers, ship-to-ship transfers, or ship-to-offshore platform transfers, where you have to actually wait in the bay to unload your cargo due to heavy winds or rogue weather. This also is in line with the oil and gas industry's safety for going forward for hands-free operations. This would eliminate taglines and push-pull sticks altogether for that operation. Same case within the steel erection industry. There'd be no more Christmas treeing of your loads. You'd be able to have safe, precise tower crane erections. You wouldn't have to worry about the load ever coming into contact with your boom. No more worries about potential buckling or potential accidents on that front. Essentially, during operation while the system is on, everything will be held completely center, no matter how fast you're moving. And that goes in line also with the precast concrete business. For those full control of those large dimension loads with those high kiting factor, you would be able to control, say, if a rogue 60-mile-an-hour wind came out of nowhere, the system would automatically counteract it and bring the load back to stabilization in a matter of seconds. This is the key to faster, lightweight, heavy-duty cycles all around within the industries. We are going to be coming back out to the Gulf Coast coming around in the end of March of 2021, where we'll actually be able to do some hands-on demonstrations for you if you would like to see the system at that time. But with that, I know that that is a giant dump of information. With that, I would really like to take any questions you have this time. Me and Derek both.
How much does that system weigh? What's your deduction on your crane?
So the current deduction on the crane is 350 pounds, but with the scalable system, you would have to account for the spreader bar in between that, as well as if it's a more robust system, more batteries, it adds more weight, more fans, it adds more weight.
It was fairly light then.
Yeah,
Is it-
absolutely.
What about the intrinsically safe aspect of it for working in the plants and stuff?
Yeah, that one I would definitely throw to Derek Sikora, our chief technical officer. He is the one that created the system. He would have a lot to say there.
Yeah, if you could repeat the question one more time, that'd be fantastic.
If it's intrinsically safe, like if you're dropping it down and if you're using it out in a refinery, you got to drop it down inside a vessel or a drum or something with explosion. Does it emit sparks or is it safe that way?
Yeah, it is safe in explosive atmospheres.
Wow. Good question.
That's really neat stuff. I had never seen that before. It's very interesting. Everybody's going to the hands-free and push sticks and all that kind of stuff. I think you got a really good product here.
Thank you.
What's the
Thank you.
reach on your remote control?
Standard configuration is 500 feet line of sight, but that can be increased if you so desire with the addition of an antenna.
So like in a refinery, what would the impact be of your wireless control with all the electronics and electrical systems around it?
Yeah, so these actual, the same controller that we're using, I'm pretty sure it's already used on refineries. We know it's used on offshore rigs. It can, if you have steel obstructions, stuff like that, struts in the way, it can reduce the range. But in those scenarios, we just recommend adding an antenna so you can get increased bandwidth and range.
And one more question. So how does it know its position? Is that in relation to the crane? Does it measure something on the crane, or is it GPS, or how does it know what the position is and the degrees, if you will?
Great. Yeah, there's a few different options. So like the baseline system, what it's doing is it's measuring, inertial measurements and then basically filtering and massaging that data through mathematics. So it knows its position because you're telling it to stop or you're telling it to rotate 90 degrees. So that would be like an optically commanded position by the user. So for instance, if you're rotating 45 degrees and then you're lined up, with struts where you want to put the load down, you would optically say, okay, this is the position I want to hold. And then you would click a button on the controller that says hold. And then it would lock in on that position. And then as wind disturbances or other things come into play, it would resist those and maintain that position relative to what you just commanded. The other option is we can also hold a position in the geodesic coordinate frame. So if you're saying, you want to rotate something to, 35 degrees counterclockwise from true north, it can do that as well. But to your first point, it has no knowledge of the crane.
So Derek, I heard Hayden talk about using the spreader bar, and so I guess my question is, can you take and attach it to a spreader bar, one on each end, so it doesn't have to be part of the load, and you can lift larger loads and still use the device to position the load?
Yeah. In fact, that's one of the configurations we highly recommend, especially for the larger loads. The spreader bar is a fantastic device to attach our system to. In summary, with the system, we built it to be highly modular. The pictures that you saw today is just the baseline standard configuration, but basically you just can cut and place these modular, battery propulsion systems and attach them to anything you want with a pretty quick mechanical attachment.
Okay. Good. Any other questions?
Derek, I have a question for you.
Okay.
Question I have for you, Derek, is so what you're saying that the coordinates can be locked in and that is done like in a pre-lift, or the person on the ground has complete control of the load?
Yeah, so we try and make the user interface as like simple and intuitive to use as possible. As you can see in the controller, Hayden, if you wanted to double back a couple slides, bring it up. You know, just a few buttons. So really there's a ground operator, it can be a crane operator that is either saying they want to lift the load and then rotate it counterclockwise or clockwise, and then they could either fix it, hold it, or just put the system in standby. Now, you know, if you want to do a pre-lift plan and, you know, program in, you know, you want this system to be lined up with a 35 degrees counterclockwise from true north by the time the crane stops, and have it all, you know, be fully autonomous, we can, you know, absolutely support that. But what we always find is once we put the pen in somebody's hand and, you know, can essentially train them in how to use the system in 30 seconds, it's really intuitive and easy to use with just, you know, rotate clockwise, counterclockwise, and fix.
Sounds great. Seems like to me this would be a great tool to have in the toolbox. And so in other words, that your flagman is now going to be the controller of the object.
Absolutely. It could be the flagman himself. It could be the rigger. It could be, honestly, the operator in the cab. Really, it's all a key to whatever your operations are.
And the parameters of the wind, it goes and coincides with the crane itself. So how does it know that situation?
With the wind, it's
Yes.
is the resulting motion that the wind causes.
Results in the motion. So in other words, so if you have like a crane with the limitations of 20 miles per hour, that this shows no concern for anything. It can handle the winds up to 20 miles an hour.
Yeah, absolutely.
Very good for the offshore and for the Gulf Coast as well. And I mean, that would really make it really good for like using on flares and different things like that in areas where you put people in danger to try to turn a load. So I see that this is a really great resource to grab into. Now, is this going to be something that's going to be available only by purchase, or do y'all see a rental situation with this?
So we actually do have a leasing option available for this unit, as well as the direct MSRP for it.
So in other words, we have the ability here, if you have a project and you're doing some planning on it, and you have your lift supervisors and your engineers working together, they could team up with you guys and you would provide the engineering to show that this situation will be intrinsically safe. It will save you the opportunity to put people in there and the data that would make everyone rest assured that this is the right tool to fit the project.
Absolutely.
Sounds like a very good tool. So I guess I'm gonna let y'all go with that one. And the next person has some questions, it'd be great.
Got one more, I guess. The remote, what's the range on that? If you're working on top of 350 foot tower, is it going to work from the ground up to control the turbines?
Yes, in that event, the standard range is 500 feet, but you can just add an antenna to the controller, similar to like a radio antenna, and you can increase that range by thousands of feet.
Also, at that point, you could also have another remote with another rigger at the top of the tower, and somebody could be guiding the load up to them. But then once it gets out of eyesight for him, you could switch over to the secondary remote and guide it in with that as well.
What kind of safety checks do we have to do before we're going to lift our load? You know, just like the case that they just set 330 feet up high. You have to inspect your rigging basically always. What kind of safety checks are in place, or how do we know that this unit is going to do what it's supposed to?
Sure. There's a short answer and a long answer to that. The short answer is there's a standard starter procedure and system checks that this device already does. It's highly autonomous, and when it starts up and goes through its procedures, it's monitoring all of the onboard safety systems, what we call our safety management system, 100 times a second. And if there's any issue in the safety management system, it's going to report that to you and, come up as a very noticeable red blinking light on your screen. And then in terms of rigging and lifting, it's just standard rigging configurations that we recommend. And there's like a one pager on it and how to rig your loads.
So on the picture that you have on the screen, how is it rigged? So you got the slings going up to the hook, and then is this likewise on the hook, or you got it rigged to the slings, or just secured to the slings? How's it rigged?
So in the picture you see here, we have a central load column. So it's our own piece of manufactured carbon steel that has a factor of safety of 5 to 1 and is proof loaded 2 to 1. And then that just hooks up directly to the head block of the crane, whether it's a main line, auxiliary line, really doesn't matter. And then we have decoupling swivel points. So when we rotate a load, we don't rotate the head block at all. And then we just have a Gnebo attachment points on the bottom of our system for you to hook up whatever type of lifting gear you so desire.
Okay, so when we talked about weight earlier, your system is really weight dependent on the type of load we want to pick up, because your frame is going to be heavier. What are your load ratings on your frame?
Yeah, Hayden, if you can go up a slide, up again. Got it. So this is standard configuration here. This one ranges between like 350 and 400 pounds. And it can lift 25,000 pounds. To give you a sense of the overall dimensions that you see, it's about 3.5 feet wide by 3 feet in length, and then a 1.5 feet tall. If you want to change the rating of the system, see that central, what we call the load column, it looks like an I-beam piece of steel. Yep, there you go, Hayden. With the attachment points on the side and the bottom, you simply swap that out. And the 25,000 pound capable one, which again is rated to 5 to 1, so it can lift its yield point is theoretically 125,000 pounds. It weighs 120-ish pounds. And if you switch that out, you want to go up to 50,000 pounds, 60,000 pounds. That is the core component you're switching out. Or like Hayden mentioned, you just cut the system in half and can attach it to like a spreader beam or existing lifting gear.
Looks like you have it arranged right there quite well, but we have from a single pick, and then you have a 2-leg pick right there. So you could accommodate just about any object in the 33-ton category. Should be no issues with 2 slings. I was looking at that and I said, man, that's a really good setup right there, because you have the ability to go straight vertical, and then you have for 2-leg bridle setup.
Absolutely.
I know we got some more people out there got some questions, because this is a very this is something that's going to be stimulating a lot of thought here from everybody when they leave this meeting here for sure.
Yeah, this is Clint. Say you got your Connex that you're moving. It's got a big surface area, and it's catching a gust. Say you're in 20-mile-an-hour wind, and you get a 35-mile-an-hour gust. How's that gonna control that? Is it going to have enough strength with them fans to move it around and stuff, or keep it under control?
Short answer is yes, absolutely. In fact, that's one of the design purposes of this system. Hayden, if you want to go down to the concrete wall assembly, that's a great wind sail example. So this was a demo we did for Miller and Long Construction out east, and we lifted this wall assembly and held it in winds really ranging from couple miles per hour to probably up to about 12. And it held that same exact position for 5.5 minutes straight while we had it in the, position hold feature. And that's a very large wind sail area. And during that time, the system is constantly, as the motion is sensed just by like 1/4 of a degree, so just something that slight, it's going to bring it right back.
That's a good question there, Clint, because what I see here going on is like this is the tool to work in parameters of the lifting hole equation. This is something that if you do have a wind sail problem and you're trying to make a lift with a load and push your crane, then you're going to have a problem. So this has to be all encompassed in your pre-lift meeting in your load, because there has been many times that we've had the crane within the guidelines of the wind, but because of some gust that may come up, you can't lift your load. So this could possibly set the stage for you to make a safe lift and cut down a lot of downtime. You would just be waiting on a situation where the wind may not be quite dying down as much. Very, very good.
We just had somebody text in a question. Could it be programmed to communicate with the crane's computer? The answer is yes. Might have to install, a wireless communication device on the crane's computer if it doesn't already have it. But these crane systems tend to be modular as well. So yes, it could be programmed to communicate with the crane's computer. And moreover, we could replace the crane's the control sticks, or add a few control sticks so that you can control the device from the cockpit.
Any other questions out there?
Well, that one right there, that statement right there really intrigues an old person like me. Okay, so Mr. Derek, give me a little breakdown of what you're saying is that the operator could just be sitting in the seat and that this could work with the crane's onboard computer system, and he would not be swinging, he would not be picking up a load, that this could be teamed up with that. Give me a little bit more analogy on how that's going to work.
Yeah, sure. So you can basically think of it as rather a separate system from the crane as an integrated device with the crane. So the crane right now, right, you have your boom controls, other various crane controls, the line controls, etc., all within typically like a 2-stick configuration. Where on that stick, on those control sticks, you have a few switches and controls. We can add, say, like a wheel on one of the sticks to go clockwise, counterclockwise, and then a simple button, so that you can control the orientation of your load and command and position hold from the crane. With that being said, that might require an additional piece of hardware being installed in the crane cockpit, which is just an integration thing or like a maintenance procedure for the crane.
Wow, that's some technology that was way beyond that I thought it could even happen. But when you go to doing things like that, you cut off the ability for a human to visually see something, and you're letting it all run by the age of technology that we're in. I thought I would never see a situation like that, because I was told many years ago that my job was going to be in danger because of the progression of there going to be computers that are going to be able to have functions of the crane. And I perceive that thought process is highly unlikely, because someone always has to be in visual control. And you put more, I think, you're putting a whole lot of value that your system is going to work good. Because I know whenever I've tried to even set the swing limitations on a crane, that don't go too good. And it really has some concern for me to try to even go in that kind of a mode. Do you foresee this ever really being something that is going to take a path forward into the crane operation? And, you know, in order with the OSHA guidelines that we have now, I don't think that could be done, because you have to have the crane operator in control of the crane. And is that just something I'm thinking of because of me being biased, being a crane operator for 45 years, or is that something that other people may chime in on?
So a couple points of clarification here. Our goal is to make the crane operator more effective and in control of his load. We're not automating the crane operator's job. The crane operator is still, you know, the master and control of the operation. We're just giving him, you know, more ability to control the load that he's picking.
Yeah, I can see that being quite a challenge, and I can see that, you know, some things could go wrong with that situation. I mean, it's great that that ability is there, but as a use for the flagman, I think it'd be a valuable tool to have in your deploy.
I would say in the regulatory sense, this would fall under the line of an operational aid, correct? And the requirements for inspection and maintenance and use would fall under the same as operational aid, perhaps a safety device. Does anybody have any thoughts on that?
It's definitely a load handling device, so that's a correct statement.
Okay, thanks.
Yeah, it looks like a game changer for sure. Any other questions or comments? Beth, did you have something else?
No, I did not. Thank you.
Okay. Anything else to add?
In a personnel basket, if you put the controller up there with the guys in the basket, because you know, when you get out there, you get close, everybody's reaching out, trying to position that man basket where it needs to go, and then get tied off and hold themselves where they need to be so they can work. That should keep all your hands inside that basket, and the guys that's up there in the air be able to spin it around and get where they need to get to work on whatever they're getting to. I think it'd be real handy for that.
And that is definitely the idea there with that first photo that we have. Essentially, like what you stated, they would have it in the basket with them, and they would have full control rotational wise, so that they wouldn't have to have you move the crane between the picks. And again, like what you stated, everybody is all contained within the man basket at all times.
Yeah, because I mean, you're in those baskets, you just kind of swing it up against the structure, and everybody's trying to catch it and hang on and get where they need to be while the operator's trying to adjust it. You know, it's just all you can do. I think it's get in there, you'll be able to kind of maneuver yourself around. It'd be kind of neat.
Absolutely.
How loud is that thing? Speaking of that, if that's right above your head in a man basket.
Yeah, so it can be pretty audible depending on how chaotic the winds around you are. I mean, if you're just rotating a man basket doesn't take this thing very much work. We likely wouldn't exceed, 15 to 18% of our, propulsion capacity. I would compare it to a more audible computer fan.
Wow.
If you were working in this basket with this thing above you, wouldn't you be considered working under a load?
That would go like under like a load handling device, which would be, presumption you're going to be working under. If you have the crane basket attached to the block and the people were in the crane basket to begin with, it would be the same thing. It's just like, I could see what you're saying, But that's with any basket work, you're going to be under the load because there's no other way to accomplish that lifting detail.
I can just see people frowning looking at this big object over their head that's hooked to a choker up to the ball and considering that a load over their head.
And with that comfortability wise, the device is modular in design. We could essentially just attach it to the man basket itself at the bottom and still have that precise control of the man basket.
Now I see what you're saying, Russell. You know, but it is a pass through. I mean, you got the load line hooked to the beam and then the beam hooked to the basket. But yeah, it would probably be best in this situation to have it attached to the bottom of the basket and not be overhead. Because you're gonna have that safety, choker tied to the basket and then go up above that as well. So
right.
Well, you're going to have in order to have the check off on your basket, you're going to have the rigging that is going to be there attached to the basket. You know.
Yeah.
I don't really see how that's going to be effective to attach it to the basket because you got to have headroom for the people to stand up in the basket. You know, that's just something that's going to have to be agreed upon. You know, and bought. To me, it's a lifting device. This thrust propelled stabilization unit has a 5-to-1 safety margin, and it actually from the size of the master link at the top and the master link at the bottom for single use. What are those, Derek? What are those good for?
Same rating. So when I talk about the rating of the lifting device, it's we rate the working load limit to the total assembly, not individual parts. So it would be, in this case, is the 25,000 pound configuration.
25,000 pound configuration. So you have a 25,000 pound configuration, and that's roughly of the crane load hook. That's probably about 4 to 5 times the overrated capacity of the ball hook. So, the failure situation, I don't see it. Now, that would be a challenge that I would say that a safety engineer would have with individuals working in a basket. And that might be something you guys need to, how would you say, employ the use of some safety professionals and stuff like that. And that'd be a great topic, for possibly if you guys come down here by the time that we're able to meet again and we give ourselves a review of the situation and think about it. But I see it no different as like the crane hook. The challenge to be working underneath something, the benefit of having people in a basket where they can take charge and not have their fingers in their hands. And if you ever been up in a basket, and it don't take but about 10 or 12 miles, and you'll see the difference of what it does when you go smashing into the handrail on top of a flare stack. That'll give you a little bit of a draw, make you pucker there pretty good. So I'm real pleased to see this new tool to be able to work with. Thank you guys very much.
Yeah, of course. Are there any other questions?
To cap it all off, our colleague Shelby Mounts just posted in the Slack to touch on maintenance procedures. This device has 6 total moving parts. It's extraordinarily easy to maintain. What we would essentially do for maintenance is have spare boxes on site in the event that one goes down. There's no reason, like for instance, in crane maintenance, you essentially open the hood to maintain some contactors or engine components, stuff like that. Not the same here. you ever have even the slightest of issues with a box, you just replace the box and call us. And there's only mechanical attachments to the frame that need to be had. And then you can see there's a one singular cable connection on each box that connects the two together for them to communicate. And that's it.